Morning, everybody. This is a brainstorming question. Anyone of you, if you have tried, because this is going to be a controversial question, a very conceptual question. So let us decide in today's class. We will do it, this problem. And with the answers, any approaches. If the volume of the piston is decreased by 1 meter cube, what is Q reversible of the system? That was the first question. In my opinion, I would say the opinion, it is 460.6 kilojoule. So let us start with this answer, 460.6 kilojoule. The answer to the first question is 460.6 kilojoule. So now you can tell how to approach the problem. What is this problem is all about? And what is the funda of this problem? So this one problem has been chosen to really find out what is electrochemistry, the general principle of electrochemistry. So as you can see in this problem, basically there is a concentration cell. And in this concentration cell, there is a, suppose, platinum electrode and H2 gas at certain pressure, say P2 ATM, and then H plus middle chamber, and then we have H2 gas with P1 is equals to, say, some ATM, P1 ATM or bar, and platinum solid. So basically the question is about a concentration cell. So in this concentration cell, you can see the EMF of this cell, E0 cell, we already know, is always 0. And EMF of this cell, E cell, will be given by minus RT upon NF 2.303 log of whatever it is. So here in this particular case, H2 is chaining into twice of H plus 2 electron left hand side, and twice of H plus right hand side plus 2 electron chaining into H2. Something like this will happen. And we have H plus left and H plus right is same. They will cancel. So this is right denominator. Pressure of H2 in the right and pressure of H2 in the left. It will look like this. The concentration cell. So definitely E cell is not going to be 0. And E cell, if you calculate, will be given by minus RT into 2.303 upon 2 into F, and this is log. I believe that it was 2 ATM, 2 bar and 0.2 bar. So pressure in the left hand is 0.2. So this is 0.2 and this is by 20. So that is coming out to be how much? 100. This is 2 by 20. I mean, this is coming out to be 2 into 10 to the power minus 1 upon 20. 1 by 10 to the power, that means this is going to be 1 by 100. So that means you are going to get 10 to the power minus 2 term. And finally, you are going to get plus RT upon 2F 2.303 log of 10 to the power 2. This 2 will also be cancelled. So it is RT into 2.303 log 10. That is the EMF of this cell. All right. These all things are quite easy to comprehend. So, but the thing is, what is Q of the system? This is the most important thing. Is Q is involved? So it's a very controversial question, and I would like that you should come up with the opinion. What is there and what is the status? You have to be very, very thorough in your, theoretical part, and especially this Q reversible part, to get the answer. If the volume of the piston A is decreased by 1 meter cube in joules, what is Q reversible of the system? So before we do this, should we develop the theory of this? Otherwise, the questions will look, without explanation. So let us try some theory part of this one. So what is the theory part of this one? That we know that delta U is equals to Q minus PdV. When we write it, it is only involving non-PV work. Sorry, only PV work. When only PV work is involved. So if non-PV work is also involved, delta U is equals to becomes Q minus PdV. In fact, integral of this, and this is integral of this, I should write it like this, integral of this, and minus W dash non-PV. There is a special reason why we write it minus W dash, because this W dash non-PV is equals to electrical work or non-PV work done by the system. So that is why we write it like this. So this is the idea. If delta U is like this, what about delta H? Delta H is always equal to delta U plus P2 V2 minus P1 V1. And generally speaking, if the pressure is constant, then delta H is equals to delta U plus PdV integral. So that is delta H. If these basic questions are involved, so we have to think about these two things. So I think that you will help me out in finding the answer to this question. That is a very important thing. You should help me out, because delta H is equals to delta dq minus PdV and W dash non-PV. So in this first question, suppose if somebody asks you, so that is often a surprise to the question if somebody asks about delta U involving the non-PV work. But that's the reality, that if we talk about the internal energy process, the internal energy change in the process, so of course non-PV work is involved here, and we should be considering this. Now the question, another question here is this: if we take it still further and we take it to the delta G, so delta G is equals to, delta H minus T delta S. In fact, the perfect recipe to do this is write G is equals to H minus TS. And then differentiate. dG is equals to dH minus TDS minus S dt. We often used to do this. So this means that dG is equals to du plus PdV plus PdP minus TDS minus S dt. And then dG is equals to, we can also write du, instead of du we can write dq minus PdV minus W dash non-PV plus PdV plus VdP minus TDS minus S dt. So this PdV term cancels out. Even if it is there, it will cancel out. And this dq minus non-PV and this TDS and STD terms are also already there. Then we write that dG at constant temperature and pressure. If we additionally apply this condition, then this term will vanish and this term will vanish. And we get to this point, dq minus W dash non-PV and minus TDS. We get to this point. Up to this point, this statement looks very good. That says that change in Gibbs function is equals to heat absorbed by the system, work done, non-PV work done by the system, and minus TDS term is already there. Now from the second law, there is a very important principle. In the second law, anyone tell me what is the relationship between dq and TDS? dq and TDS. Is there any relation between dq and TDS? Anyone?
Yes, sir.
What is that relation?
ds is dq by t if it is reversible process.
Very good. And if it is not reversible process, then
Then we need to change our path.
change our path. Okay. So the Clausius inequality term from which the second law comes, which says that, which always tells us that dq by t, just a minute. What is the Clausius inequality? Sum of the dq reverses by t is less than 0. So this is. I'll have to derive it. Sometimes I forget and I could not take risk. Okay. So there are two ways doing it the standard way, and I think this is a very important result.
ds is greater than equal to
Yeah, very good.
dq by t.
Yes. Thank you. ds is always greater than dq by t. Fantastic. Okay. So this result comes from where? This result comes from where?
Carnot cycle we
Carnot
derive.
cycle. Carnot cycle. When we write q1 upon t1 plus q2 upon t2 is equal to 0 for the reversible cycle, and it is less than 0 for irreversible cycle. So there from there. And the shortcut is, if you just forget it, do it proper way, then what you should do, simply write ds system plus ds surrounding is always greater than 0. That means ds system is always greater than minus ds surrounding. And we know that ds surrounding is nothing but minus q dq by t. And that is minus dq by t, and this minus will become what? Positive. So that is a very interesting statement, that ds is always greater than dq by t. If ds is always greater than dq by t, then obviously you told me that tds is always going to be greater than dq. If tds is always going to be greater than dq, then this statement is another very important statement. If that is the case, then can we write that dg at constant t and p is equal to dq minus dw dash plus minus tds. And now if we take these two terms, and we already saw that tds is always going to be greater than dq. If tds is always going to be greater than dq, that means what? This is tds minus dq is going to be greater than 0, and that means minus tds plus dq is going to be greater than what? 0. And minus dw dash. Situation become like this. Still,
Less than 0,
why less than 0?
tds is greater.
I have written it like this. Oh yes, less than 0. Done. You are right. Good. Because from there you can see that minus tds plus dq is going to be less than 0. Yes. So if it is going to be less than 0, there is a very interesting proposition now. Okay, this is the point, theoretical point. Good. Now suppose the Gibbs function change is minus 100. Suppose, and since temperature and pressure is constant, and we know that G is a state function, this minus 100 is a fact. Whatever way you try to do it, whether it is reversibly or whether it is irreversibly or by different other paths, this is always going to be minus 100. So that means that minus 100 is equals to something like this, and this is going to be a positive electrical work done. So there is a negative sign. Situation is like this: minus 60 minus 40, minus 80 minus 20, minus 90 minus 10, minus 95 minus 5. What I want to say, you understand and tell me in a very simple manner. What is the meaning of this? The meaning of this is, if you take the process to be reversible, because TDS minus TDS plus DQ value will be what? One more thing. And one very interesting thing, 0 and minus 100. This data I forgot. That's what I want to say. So see this statement, what it is telling. Anyone who can tell me what I want to convey by these descriptive things?
Maximum work is done in reversible process.
Yes. So maximum work is done during reversible process. First important thing is this. And if you're not doing this process reversibly, then what is happening? The kind of electrical work you are going to get will be less. Electrical work will be less. And then the process will be, then what will happen? The losses will go where? So that means you're not getting electrical work. So you're going to get what? Work in terms of what? Heat and all this. So heat and all this are going to be the primary source of energy. And that is why we write very carefully that during the process, if during any process, the decrease in Gibbs function at constant temperature and pressure is equal to the maximum possible amount of work which can be done. It is not like which is done, which can be done if the process is carried out reversibly. So such a long story I tell you because this is a very fine point. A very, very fine point that you will get the maximum work only when you carry out the process reversibly. Now tell me that can anyone tell me that can you really carry out the process reversibly? Can you really carry out when you are operating your batteries, when you're operating your car, are you carrying out reversibly?
No, sir.
So if you're not carrying out reversibly, that means we are not getting the total, maximum amount of work which can be delivered. Only a fraction of it can be delivered. Okay. So this is the idea of this whole process. Now going backward to this one. This is the idea of the non-PV work. And from there, the whole electrochemistry generates non-PV work. So this problem is all about this non-PV work. I have already written answer, but I have not shared the answer because I need some time to, go into this one and really figure it out. So this is going to be a controversial question. First, I would like to hear your own account that one thing at a time. How we are operating this galvanic cell? Are we operating it reversibly or irreversibly in this problem? Anyone? कैसे चला रहे हैं हम इसको? रिवर्सिबली चला रहे हैं या इरिवर्सिबली चला रहे हैं? क्या लग रहा है? अगर आइडिया नहीं है तो आप किसी सिंपल ऑर्डिनरी गैल्वेनिक सेल को ले लीजिए and you develop your theory from there and then apply it here. Why to use it if it is complicated? Let's talk about this. Any simple copper zinc galvanic cell, and let's talk about can we operate a copper zinc galvanic cell reversibly? What is the meaning of that reversible process? So see, that is why I made this question, because most of the time we have calculated, but we have never calculated delta U most of the time. Delta U in terms of what? Heat. If some heat which is there in the bond is directly getting converted into electrical energy, how the delta U and delta V will change. Okay. So that is the whole idea of the problem. And another problem which is there in this problem is, which is going to be addressed when you find the answer of this, then you will be totally clear about this fact also. Another interesting thing, second law. So second law tells us that delta S system plus delta S surrounding is equal to delta S total. And if a process is reversible, then delta S total is always 0. Because if you violate this, you're violating the second law. If the process is reversible, then delta S total is equals to 0. That's a fact. So that means anytime if the process is reversible, delta S system must be equal to minus delta S surrounding. So we have to figure out in this particular operation, what kind of thing is there. Is this a process reversible? If the process is reversible, then delta's total should be 0. If the process is irreversible, then the system's delta's total is not equal to 0. Okay, so what do you think? This process is reversible or irreversible? So we have to see to it what is a reversible process. So see, this question is challenging the idea of what is reversible, irreversible process. When it comes to ideal gas, it is very difficult, very easy to figure it out. What is a reversible process? You gradually change the pressure. So you have very exact kind of things. But when it comes to the electrochemistry, which is going to relate the thermodynamics part. So that is why this question is. Now, frankly speaking, I got an answer, but I got an answer. I think that there will be some objections to it. That what is the answer? That is why I'm discussing the theory. First, you become clear of the theory, then you can accept that answer. Otherwise, it is very difficult to accept the answer. And you will say that, sir, this is going to confuse me a lot. So my advice is key. First, you get the theory part clear about this question. The kind of, the logics I'm talking here. So let's make it clear. Is it a good idea that we should take one zinc copper galvanic cell and learn something about there from there? And then we come back to here. If I ask you, suppose this is zinc and copper 2+ ion is there, and there is Zn2+ ion and copper is getting converted into this. This simple thing is going on in a galvanic cell. Salt bridge is there, and there is a potentiometric circuit. And in potentiometric circuit, we can actually virtually control this process. How we can control this process? So, Bacho, if you like it, then only give about this one if you have done already the routine work, okay? Because never try to. So see, there is a potentiometer. What is the role of potentiometer here? Anyone? Quickly, very quickly. We are less time. What
To
is the role
provide suitable resistance.
to provide suitable resistance? No, basically this potentiometer is going to do what? It is not allowed to current to pass through this galvanic cell. So when you see the definition of EMF is the potential difference between two open-ended circuits. Open-ended circuit means what? The I is equals to what? 0. So you really want to find the potential difference between this electrode and this electrode as simple when the net current passing through is equals to 0. So the potentiometer is going to do what? When you are balancing this arm, okay, when you are moving it here and there, then current is flowing in opposite directions. At certain point, which you call the null point, there the potential drop over here and here will be equal to potential drop over here and here. Okay, exactly equal. So the current flowing through this I will become 0. Is that point clear? Then I will move ahead. Because I still want your indication.
Yes, sir.
There will be some point at which there is a null point, and from there you can say I is equal to 0. When I is equals to 0, that time you measure the potential and you say that this is the EMF of the cell. Okay. Now from that null point, if you just move it to a very slight value, okay, towards left and towards right, okay. So guide me, because you are more into this one. Suppose this is right hand side and suppose this is left, okay. So I hope you're not confusing. So this is probably right hand side, towards right hand side, and this is towards left hand side. So if you move it towards left hand side, then what is going to happen? Potential drop from the external circuit will drop, and then current should, this voltage will become stronger. This particular voltage will become stronger, and immediately current will flow through this also. And current will flow, that means what? This is negatively charged and this is positively charged. So current will start flowing like this. That means charge will start flowing like this. Am I clear? Please give indication quickly. If I
Yes, sir.
slightly move towards the left hand side, then current will start flowing. And if I just make that correction, move towards the right hand side, then what will happen with Prakash? Yes, sir, you are responding. What happens if we move it right hand side? Anyone?
Current in reverse direction.
Yes, current in reverse direction. Current in reverse direction means what? This galvanic cell will become what? Electrolytic cell. Everyone know this? Okay. Is that clear? Current in reverse direction means what? This electron will be then pulled back here. Is that clear?
Yes, sir.
That means this, which was anode initially, that anode will become what? Cathode. And so this galvanic cell will become what? Electrolytic cell. That's the interesting point. So can we say that we have controlled the chemical reaction? We have controlled the chemical reaction. At our will, we are moving this chemical reaction from one direction to other direction. That because zinc want to oxidize and copper want to get reduced, okay, but we have stopped it. The galvanic cell is a place where we have stopped it. We are not letting this process happening. That's the interesting place, which is called galvanic cell. Okay, why I'm describing this? Because I'm going to ask you now, can you say that this process, we are carrying out this process reversibly? Galvanic cell is the place where we can carry out a chemical reaction reversibly, probably. We are stopping it, then letting it go, and then we are carrying out this process reversibly. Think about it and give the answer. Can we carry out a process reversibly in galvanic cell? Okay, you are still thinking. Every one of you is still thinking. But this is the galvanic cell and how it operates. So in this galvanic cell, if I ask you, Zn plus Cu2 plus changing into Cu2 plus, Cu plus Zn2 plus. What is the delta RH of this process? What is the delta RH of this process? What is delta RU of this process? What is the enthalpy change in this process? What is the internal energy change in this process? What is the Gibbs function change in this process? So probably you know everything about this, but you never talked about this and this. Now my point blank question is that in order to answer this question, we also must know what is delta RH in this process. So your answer will be, can be, sir, this is a chemical process. If the chemical process is happening, then delta H will definitely change. Nobody can stop it because delta H is a state function. Do it whatever manner. If zinc and copper is reacting and copper is formed and Zn2 plus is dissolved, then delta H will definitely be the same as you carry out in the chemical reaction. There is no doubt about this. So if there is a chemical reaction and there is delta RH, so that delta RH will be exactly equal to this. Do you agree with my contention or not? Do you
Yes,
agree?
sir.
That doesn't really matter. You, sir, carry out whatever way. Delta RH is going to be the same. Similarly, can you apply same here for delta RU? That do whatever it is. You take out current, you take out heat from this, but delta RU will be simply equal to the value which it could have when you carry out this reaction in chemical process, in a simple chemical manner without galvanic cell. Mix zinc and copper, and whatever is the delta RU will be delta RU, same. So same, delta RU and delta RH has the same value. They are not going to change. They are not going to change. But what is their relationship between delta? What is their relationship between this electrical work done? From there, I think relationship you will get from here, that we are lucky that we know that this is going to be W dash non PV and with a negative sign. Why? Because we are carrying out this process how? Reversibly. We are carrying out this process reversibly. So delta RG will be minus W dash, this one. And so we got a relation minus W dash non PV, which is going to be minus N into F into E, whatever it is, E, and that should be equal to delta RH minus T delta RS. So entropy term has also come into the play. Entropy term has also come into the play. Okay. So that is the idea. Entropy has also come into the picture. Some entropy change must has been taking place. And what about this entropy change? This is systems or surrounding. This is delta S system. No doubt about that because it is written in this equation. So this is the idea. So if I ask about a zinc copper galvanic cell, if I ask you what is delta G, you will find it simply minus NFE. If I ask you what is delta RH, you will simply go and read the value from the chemical reaction. You will get delta RH. If I ask you delta RU, what you will do? from delta RH, you can calculate delta RU, because there is a relationship between delta RH and delta RU. Delta RH is equals to delta RU plus delta NGRT. You will probably apply this formula, or if it is not applicable, some other formula to get the value of delta RU. But when I talk and ask you what is delta system, what you will say, then you will probably calculate delta G and delta H. You do it minus delta H, and you will get delta S value of the system change, systematic change, you will get it. And if I ask you delta surrounding, then what will be your answer? And if I ask you delta as total, then what will be your answer? That is what I am going to ask here. What do you think? Most controversial part. What about the delta as surrounding, and what is delta as total in this particular process? Anyone? If you're carrying out this process reversibly, if you are carrying out this process reversibly, what do you think is the entropy change of surrounding? That will
Negative,
entropy change of surrounding negative.
negative of delta S system.
Negative of delta system.
Yes.
Okay. So that means you are saying delta total is equals to 0.
Yes, sir.
And because the process is carried out reversibly. Because the
Yes.
process is carried out reversibly. So can you explain how surroundings entropy is getting negative? How come it become negative? Because I think we never lose any heat to it.
We have a delta H, so
We have what?
delta H, so we gain heat.
Okay, you are saying that delta RH was equal to negative.
I mean, whatever it is, it will provide delta S surrounding. I mean, delta H is Q here, constant pressure process.
Delta H is equals to Q here, but the irony here, Q is not involved. Q is not involved at all. Because Q was not involved. That is the crux of this problem. So if you are convinced here, then only what answer I'm going to propose, you're going to be convinced over there. What is delta's total in this process? If we carry out hypothetically, you're absolutely right. Delta's total should be 0. But if delta's total is equal to 0, there is some value of a delta as a system. You can virtually see that. What about delta surrounding? You will say that whatever it is, the relationship between this. Okay. So what it is, negative or positive? But actually, when you are carrying out this process, and if your system is this, it has not lost any kind of heat. कोई heat इसने lose ही नहीं करी. It has not lost any amount of heat. So if I ask you and challenge you that delta surrounding is equals to what? If Q, एक और formula होता है, delta surrounding is equals to minus Q actual divided by T. That's a very important thing. Whatever process there is, the reversible process is there. Okay. If reversible process is there, then delta surrounding is equals to what? Minus Q reversible by T. And if irreversible process is there, delta surrounding is equals to what? Minus Q irreversible divided by T. So we say that delta surrounding is equals to minus Q actual divided by T. We used to say this. So what is the catch here? What is the catch here? What is the paradox it seems to be? There seems to be a paradox that delta's total, if delta's total is equals to 0, what we are doing, what is our approach? If we are carrying out this process reversibly, then of course in reversible process, the delta system and delta surrounding should, sum of these two values should be equal to 0. And if this reaction is carried out, दोनों का सम तो 0 होना चाहिए. एकदम सही बात है. बट हमें दिख नहीं रहा कि कोई भी हीट सराउंडिंग में जा रही है. कैसे एक्सप्लेन करेंगे? और अगर सराउंडिंग में कोई भी हीट नहीं जा रही है, then what about the system? तब सिस्टम का भी डेल्टा जीरो होना चाहिए, एंड सिस्टम का डेल्टा जीरो होना चाहिए, तभी ये आप जस्टिफाई कर पाओगे दैट एवरीथिंग इज जीरो, बट इट डजंट सीम्स टू बी। सिस्टम का एंट्रोपी चेंज तो जीरो दिख नहीं रहा, बिकॉज एंट्रोपी चेंज तो हो रहा है, एंट्रोपी चेंज तो सिस्टम के भीतर हो रहा है, और इसका मतलब सराउंडिंग के भीतर भी एंट्रोपी चेंज होना चाहिए, नेगेटिव, तो नहीं दिख रहा। चलिए, तो ये हो गया एक बड़ा ही कंट्रोवर्शियल प्रॉब्लम, बहुत ही कंट्रोवर्शियल प्रॉब्लम, जो पूरी तरह से थर्मोडायनेमिक्स में टेस्टिंग कर लेगा। जो आप फॉर्मूले यूज करते हैं, जितने भी फॉर्मूले यूज करते हैं, उनकी टेस्टिंग कर लेगा। तो इनएडवर्टेंटली ये क्वेश्चन एक बड़ा ही खतरनाक क्वेश्चन बन गया है, और इसलिए आपको इसके आंसर्स को देने में बड़ी केयरफुलनेस लगानी पड़ेगी, एंड दिस इज वेरी मच ऑन द कार्ड्स। ये कभी ना कभी तो आएगा, because we most of the time we talk about the galvanic cell, most of the time we talk about the reversible entropies and all this. So that is why I made this problem, but and then I realized that I wrote certain answer, and I myself got confused into this one. So still figuring it out how to answer this question. Anyone of you who can do it better than me? Otherwise, I have some answer I will share with you. Anyone? I think you understand this problem, or you are clueless. You want some time to think about it. You go and search on internet. Really, want to find out what it is. Don't waste your time. But if you still think like this, that we still want to think over this and tell exactly what is happening. I have discussed few things, but please, your examinations are round the corner. So I will write these formulas which is not going to change. Okay, to keep it in mind, delta S system plus delta S surrounding is always equal to 0 if process is reversible. As simple as that. This is a fundamental fact which will never change. Only problem is when you are carrying out a chemical reaction, A moles of A plus B moles of B chaining into C moles of C plus D mole of D. So you can do it two ways. You can do it two ways. First, you can do it what? In the ordinary fashion. When you do it in ordinary fashion, there will be delta RH, there will be delta RU, there will be delta RG. And if you carry out the same process in such a manner in galvanic cell, if you carry out these processes, of course, there will be delta RH, there will be delta RU, there will be delta RG. There is no doubt about that. And there is no doubt, because then thermodynamics will be challenged that these two values will be same. This is another fact that this is no doubt about this one. So the electrochemistry gives us a way of finding this delta RH, delta RG, with the help of this a very simple formula, minus NFE. So there is no doubt that minus NFE will give you delta RG, and this delta RG you can also get from other routes. Both way delta RG is not going to change. It is not going to change. Okay. Another important fact, keep it in mind. This process is carried out at constant pressure and temperature. Clearly think about it. And in galvanic cell also, you are carrying out the process at constant pressure and temperature. If you have any doubt, you ask me, sir, how can I carry out this process? Because there lie the concept. Okay, minutely see. All these processes are carried out at constant pressure and temperature. And as long as you are carrying it out at constant temperature and pressure, delta RG is equals to minus NFE. Simply used to electrical work. Okay, that very simple idea relates to this one. We are carrying out, there's no doubt about this one, and we are also carrying out this reaction at constant pressure and temperature. That is why this delta RG is matching. Okay, this thing was also clear. Also at constant temperature and pressure, there's another very interesting formula that at constant P and T, delta G naught or delta G is equals to minus T into delta S total. No doubt about that. That at constant temperature and pressure, the decrease in Gibbs function is equals to minus TdS total. You can prove it like this. You already know from the delta G definition. Delta G is equals to delta H minus T delta S. From there you get it. You put it like this, minus delta G by T is equals to minus delta H by T plus delta S. You can write it like this. This is delta S system and this is delta surrounding. So from there you get the formula delta G is equals to T into delta S total. So this means at constant temperature and pressure, if delta G is decreasing, then this delta S total is positive. You could not also challenge this. If the delta G is decreasing at constant temperature and pressure, delta S total is positive. You could not deny this.
Sir, can we say that last one?
Yes,
Because we
yes.
ignore non-PV work in this derivation.
No, 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 no. This is when we, if even if we um, carry out in the, you want to say that we have ignored non-PV work, then you will have a different thing.
Yes, sir. We'll also have a non-PV term aside beside this.
Yes, Ved Prakash, you're right. Let us derive them. Good. Let us derive them. Same thing. So delta G is equals to, if non-PV work is involved, then delta H, delta U, and minus PdV term will be there. Sorry, delta U plus PdV term will be there. And if it is a constant temperature pressure, then of course PdV term will be there. And minus W dash non-PV and minus T delta S. Should I write it like this? Okay, let us suppose we can write it like this. Because in this case, non-PV work is also involved. Okay. So delta G is equals to delta U plus PdV minus W dash non-PV.
We
And
won't get non-PV in this. We'll get after substitution delta U.
so you want that we should start from fresh. dg is equals to, from there, data point, no?
Yes,
d
sir.
equals to dh minus tds, like this one. So eventually we will get where? We will get dg is equals to dq, if I remember, minus w dash non-pv plus tds.
Minus TDS.
Minus tds, yes. Minus tds. We are at this point. All right. Then at this point, if I say dg by dt at constant pressure and temperature,
DG by T, sir, not DT.
okay, we have to calculate it related to entropy. So that will be dq by t minus w dash non pv minus td ds. And if we carry out this process reversibly, then dg by t at constant temperature and pressure is equal to this term is going to cancel. And of course, that is divided by T minus W dash non PV divided by T. So we could not relate it to the entropy.
We can write dq by T as minus delta surrounding also. This is system. If we don't cancel them directly.
If the process is not reversible, first, this is the result. If the process is reversible, if the
I
process,
mean, if it's reversible, delta is surround totally zero, so it's not looking here. But
okay, and if it is dg by T dp, T at constant temperature and pressure, if it is irreversible, then we can write it dq by T minus ds. So if we take a negative sign, this will become minus delta S surrounding, and this is minus delta surrounding we can write, and this we can write minus delta S system and minus W dash non PV. This. So we can say that delta G by T, let's call it delta, is equals to minus delta S total minus W dash non PV. Okay. So here delta G is equals to T delta S total
We add a by T for work non-PVs.
Yeah, there is another T here. But that T will finally cancel. Na?
Yes,
So
sir.
W dash non PV. So we can say delta G is equals to T minus delta G is equals to T into delta's total plus W dash non PV. Absolutely right. Yes. Thank you for this challenge. So I think that this is for PV work involved, and the non-PV work is involved, then of course delta's total will slightly be modified and this will be equal to this one. Okay. And one other interesting fact is this, that the absolute value of this will remain the same. Why? Because G is a state function. If we are carrying out the process, then this is going to be the state function. The value is not changed, but of course this non-PV work, when it has come, delta's total will be slightly modified. So here in this process, this will work. So W dash non-PV is very important, which is positive work. So if W dash PV is there, so decrease in gift function is equals to, if delta's total is 0, because of the reversibility of the process, if we carry out the process in a reversible manner or whatever manner it is, so total will be del W dash non-PV word should also be added. Yes. So the numerical value of delta's total will decrease because this W dash non-PV work, that makes sense. Yes. That totally makes sense. Done. So now the conclusions are, from this it is concluded, very interesting fact. After this, we can conclude that W dash non-PV is not equal to 0. There is always some W dash non-PV, which is not equal to 0. You're always doing this work. So in these cases, the delta G, decrease in delta G is equals to T into delta S of the universe, total means universe, plus W dash. That will be the total decrease in Gibbs function.
W dash by T.
W dash by T. Okay. So, which means also that if we carry out the process reversibly, then delta G with a negative sign will be what? W dash non-PV. If reversibly carried out. All right.
Delta S universe is not a state function.
Delta S universe is not a state function. Yeah. That is not a state function. Because state function is related to state only. And delta S universe is not a state function. In fact, delta S system is state function. We never say that delta is a state function. We always say S, because if we say delta is a state function, that's not true, because change is not called a state function. Is that clear? But we can say S system is state function, but S surrounding is not state function, because surrounding is not a definable quantity. No? Surrounding is not a definable quantity.
Yes.
So if surrounding is not a definable quantity, then universe can also not be a definable quantity. So fantastic. So this is the result. So there is no doubt about that, that if we carry out the process reversibly, then delta S universe will be 0, and there is no problem, because if we carry out, now it makes sense also, because if you start carrying it out irreversibly, then what will happen? Then this delta S universe part will start increasing, and this W dash by T part will start decreasing. But there's some remains to be constant. Clear? Clear? Is that clear?
Yes, sir.
Okay. So now we can attempt this problem. First question is, are we carrying out this process reversibly? Because this is the last question, but I would like to take, because from there the story will start. Is this process reversible? Anyone? Now we acquired a lot of theory. What is your basis of thinking that it is irreversible?
We can do practically, so it shouldn't be reversible.
But if we do it practically, then a lot of losses, heat losses will take place. Of course, we can do practically. Like zinc copper galvanic cell, we can always carry out, theoretically as well.
Those
So
reactions won't be in our control theoretically too.
reaction won't be in our control theoretically. You're right. It seems to be reaction could not be in control. But don't you think this potentiometer circuit will do something? It is maintained at certain point, at a null point. So at the null point, situations like this, that if you change it slightly, then current will start flowing in the opposite direction, because other is maintained at 0.2 bar and this is maintained at 2 bar. So if it is a galvanic cell, slight movement of this from towards left to right will make the current go in the opposite direction. So that means they are finally balanced. So if we want to carry out this process, that is why I have written in the given electrochemical cell, the pressure on the left piston is increased by dP. So it was in the pointer, the potentiometer has basically balanced these two arms. The potentiometer is quite of, it is maintaining that balance. This battery is very important here. So this battery, or its work is that the potential of this and this is maintained in such a manner that no current is flowing. If no current is flowing, that means what? No chemical reaction is carrying out. Do you agree that I'm not forcing anything? Democratically, I'm asking everything, okay? Just imagine. Now, what do you think? If you don't like it, any one of you, or you can object. So if this is totally balanced, it is a null point, then of course current is not flowing. If the current is not flowing, what is the use of this H2 gas pressure? There is no use. So it is not requiring this H2 gas. Why it will be consuming? The process is not spontaneous. In fact, you can do it by this null point, slight amount of movement here and there can cause what? Gas from there can start getting towards, piston start coming down and piston start going out. It all depends on you. Sometimes using this battery, what you can do, this battery will start doing work. So this piston will start going up and this piston will start going down. Do you agree? I'm not forcing anything.
Yes, sir.
So can we say that we can carry out this process reversibly? Yes, I think that I have convinced you.
Yes, sir.
So if this process is reversible, then of course in this process we're going to be of the maximum efficiency. We're not going to lose any part of the energy, and all the chemical energy is going to be totally converted into what? Electrical work. And electrical work we can easily calculate, because as soon as we said that this process is reversible, we come to know about the E cell. If we come to know about the E cell, we will calculate delta G. And we will calculate delta G. So we'll also calculate what? Calculation of N into F into E cell will give us the delta G value. And this is nothing but W electrical. So a lot of this can be done. So if we are carrying out this process reversibly, then what about delta surrounding? Theory
So
part.
we have enthalpy, so why there is no heat?
There is enthalpy.
But there is no heat.
Yes, there is no heat, because that enthalpy, whatever heat was there, it has disappeared into something like electrical work. We have already discussed this in the theory. That is why we discussed that if you carry out this process in a chemical cell, then whatever delta H value is there, that is going to be the same change. Same change is going to happen here. Nobody can stop it. So enthalpy is a state function. Okay. The only thing is that you are not getting heat. Why you're not getting heat? Because the way you carry it out is a different thing. So you are directly taking heat and converting it into what? The electrical work. That is why you are not getting any heat out of it. So enthalpy change will be the same. And what will be the enthalpy change of this process? No doubt about that, because the overall process is H2 from right is changing into H2 towards left. What is the enthalpy change of this process? You tell? Zero. Why? Because temperature is constant, and pressure here is equal to say 2 atm, and pressure here is equals to 0.2 atm. So simply changing the pressure will not change the enthalpy. We already know. Simply changing the pressure will not change the enthalpy, because the gas is what gas? We have assumed, already written in this problem, the gas is what gas? Ideal gas. So delta RH is going to be zero. Simply delta RU is also going to be zero. So delta RU of this process is zero. Delta RH of this process is zero. What about, because simply it is this, what about the delta system? By the same coin, delta system is not zero. Why? Because delta RS is equals to pressure difference is there, will given by at isothermal process. What is the formula? Delta S का क्या formula होता है? Delta S R is equals to N CV ln T2 by T1 plus N R ln V2 by V1. Do you agree? And
This is
V2 by
not
V1.
for a chemical reactions. Or
Yeah, it is not for a chemical reaction, and here chemical reaction is not taking place, because this cell I have chosen. That is why we have chosen this cell. Chemical reaction is not happening now.
yes, sir.
Here,
Yes,
since
sir.
H2 gas is going from right side to left side at different pressure. That is why this question is such an interesting question. You see, only by merely changing the pressure you are carrying out. So delta S here will be definitely given by N. So number of moles you have to calculate N R ln V2 by V1 means P1 by P2. So from P1 to P2, so you are going from 2 atm to 0.2 atm. This is always going to be positive. Of course, it is going to be positive. So amazing. In this question, you see this, the whole process is being carried out at the cost of increase in entropy. That was the motivation. So whatever current you are getting from this increase in entropy. That is the beauty of this concept. And that is why I like it, and I thought that I should ask it. So delta RS is here positive. What is this delta RS? No doubt about that. That is delta RS system. If that is delta RS system, very interesting, because you already told what should be delta RS surrounding. You yourself derived all these things. What do you think? What is delta surrounding?
Negative of this.
Yes. Now you will ask me this question. And I think I derived it and show you. You already derived on your own. Sir, how come delta S is negative? Heat is not going out. Kamal hai. When you are extracting something, and what you have done, you have converted this into energy. So what happened? That means somewhere entropy has decreased. Somewhere the entropy has decreased. Because when you get a random energy into ordered form of energy, that means somebody has lost the freedom. So delta is total, we have to take it is equals to zero. And this is the amazing part of this problem. And last question, which what we have derived, you have to remember this. Delta G is equals to minus W dash non-PV, and minus delta G is equals to T into delta S universe here is equals to zero. And this, you can verify this from there, that delta S universe should be equal to zero. So whatever we have derived carefully, we are just applying that. And any answer for this? So we will say that delta total net change in entropy is equals to zero, because system is going from a less random state to more random state. But at the same time, what we have done, we have just removed that energy. Energy has been removed and been stored into something like electrical energy. So of course, one side, the disorder is increasing. Other side, the disorder is decreasing. So that is why the net change in disorder is definitely here is equals to zero. And that is the special case. And delta G, decrease in delta G is equals to non-PV work. Now we are totally sure about it. Any doubts here? Any objection to this?
Sir, both the disorders were in the system.
Then say that delta's universe is zero. That is it.
I mean,
Doesn't
system is also zero then. If both were included in system, then one gained entropy, other lost entropy.
No, system's entropy change is definitely positive. System's entropy change is definitely positive.
What is our surroundings?
Now we have extracted some amount of energy and we have raised a mass in surrounding. Okay. Suppose whatever electrical work we have done, we have raised a mass into the surrounding. So what do you think? Entropy has changed or you calculate it now? Since the process is reversible, we will carry it by reversible path.
Yes. What do you mean by increasing mass of surroundings?
I mean that take a unit mass and raise it height. So it has gained some potential energy.
Yes.
Okay, from where that energy has come. Your electrical work has done that kind of thing. Convert your electrical work into that one. Okay, in the surrounding.
Can we say that is heat?
No, we will not say that it is heat.
Okay.
What is the problem? Whatever electrical work you got, okay, let us do one thing. You raise a mass against gravity. You raise a mass against gravity. Can you do it?
Yes.
Now drop it. If you drop it, entropy will increase or not?
Will increase.
It will increase. So that means when you are raising it, entropy has been decreased. That is it.
Yes.
So inadvertently, this problem has touched many different theoretical parts. Okay, many different theoretical parts. So this is what is when we slightly change and give a tadka of what non-PV work, then we get this. And you need to be totally convinced because it is a very late examination time, and that time, whatever concept you are studying, I think don't ITG is not going to, but if it is going to ask, then as I had already told you, in this way we are just brushing up our concept. We'll take one difficult, challenging question, and it will brush up our own concept. So I think that in this discussion, one thing is clear: don't be casual in thermodynamics. If you're casually studying and mugging up the formula, please be very tactful. If a problem is asked and if you feel like something about surrounding and system is asked, you're dicey, leave the problem. But only if you're so thoroughly sure about it, because thermodynamics MCQs are the most difficult one. If and but and total thing is changed. Okay. So I think what conclusions we have drawn. Let us see in this question what parts we can do. If the volume of the piston A is decreased by 1 meter cube in joules, what is the Q reversible of the system? Very controversial question. Q reversible of the system. Answer will be what? There is no problem because Q reversible is a hypothetical heat and we can relate it to what? Delta S system is equals to Q reversible by T. Do you agree? Always. So if somebody asks me Q reversible, I simply calculate delta system. Can you calculate delta system here? Yes, there was no doubt about that. Delta system was equal to NR ln P1 by P2. That was delta system, and we should multiply it by the temperature, given temperature here. That will give us the value of Q reversible. Whether that reversible heat is involved or not, another concept, doesn't really matter. Q reversible, whether it has actually come into the picture or not, but you can always calculate Q reversible. Is that clear?
And this is
Any
also
doubt?
responsible for delta surrounding. You can say that.
Yes, yes. What? Once again, please repeat what you were asked. What asked you?
Even this is responsible for delta surrounding. This Q reversible.
No, actually, Q reversible always for the system, no. Q reversible is always important for the system, no. See, Q reversible concept. You are expanding a gas in vacuum. You are expanding a gas in vacuum. You remember that question? If you expand the gas in vacuum, then of course a Q irreversible is equals to what? 0. But Q reversible is not equal to 0.
That is not a reversible process, but this is.
That is not a reversible process. Okay. So you can carry out the process in reversible manner. You can also change this state from there to there. How? Reversibly. So whatever it is, always what is Q reversible? If a process is irreversible, even then Q reversible exists. This is the most important point in thermodynamics you learned.
Free expansion can be reversible.
No, free expansion, the change in free expansion can be carried out reversibly. You have gone from
Yes.
1 liter to 2 liter free expansion. Can you go there by reversible path? Yes, why not? Do it like isothermal process. Isothermal, reversible expansion.
Yes.
Can you do it?
Yes, sir.
Yeah. So when you carry out a reversible isothermal process, that time whatever heat is involved, we will call it Q reversible. That is it. So
Yes, sir.
even remember one thing, even if a process has happened, okay? So, and I'm very sorry to do all this thing because this is going to, I think you have to once again go and revise your thermodynamics chapters. And I think that someone of you have very nicely responded. So please don't blame me for this. We are just revising kind of thing. Okay. So if you are coming from this point to this point, path number 1, path number 2, path number 3, and this is suppose an irreversible path. Okay. This Q irreversible is there. And suppose this Q irreversible is 0. That doesn't mean that Q reversible is 0. Q reversible 1, Q reversible 2, Q reversible 3 can be many values, even if Q reversible is 0. The best example of this you get where? In adiabatic process. Irreversible adiabatic expansion. Q irreversible is equals to 0. But Q reversible is not equal to 0. Had it been the case, then delta S system should also be 0. अगर Q reversible 0 होता तो डेल्टा सिस्टम भी 0 होता. क्या इसका डेल्टा सिस्टम 0 होता है? नहीं होता.
Because that reversible path which we get between those 2 points is not adiabatic.
Whatever it is, but I am saying you are right. That is, I totally understand that it is a reversible adiabatic path. This is reversible adiabatic path. But if you want to carry out the same process irreversibly, expansion, suppose you want to carry out, it will not follow any path. It will first of all not follow any path, because who knows the path of an irreversible process? Only God knows. Path of irreversible process, nobody knows. Suppose it started from state 1 and reversible goes to state 2, but irreversible will definitely go somewhat ahead of 2 dash. Irreversible will always go 1 to 2 dash, but reversible will always go from where? 1 to 2. Is that clear? You might have done it.
Yes, sir.
So at any cost you want to carry out a reversible adiabatic process, you'll always go from 1 to 2 dash. And 1 to 2 entropy is 0. 1 to 2 delta S is equals to 0. But 2 to 2 dash delta S is positive. So that makes 1 to 2 dash entropy always positive. So irreversible adiabatic process, entropy is positive, but Q irreversible is what? 0.
Sir, in our first diagram, Q reversible will also be 0. First graph.
In this
Above one.
process,
Above
from
one.
there to there?
Not sir. We draw another graph before. Yes, sir, this one.
Yeah, in this
If
one?
in reversible path we have Q reversible as 0, then every other path Q reversible will be 0.
Suppose in this path Q reversible is 0. You say that in every other path Q reversible will be 0?
Yes, sir. Because there will only be one reversible path.
First of all, I have not written that Q reversible is 0. But even if it is 0, then in all other parts may not be 0. I tell you why. Why? I tell you why. From your question, a lot of questions are coming into my mind. So that is why when students interact properly, then teachers start creating a lot of other questions. See, this one path and this other two path. Accidentally suppose Q reversible is equal to 0. That only means that total sum of the Q reversible is equals to 0. dQ reversible sum is equals to, but I have not said that the process is what? I have not said that the process is equal to what? Isothermal. So actually, when we take it, when we talk about the entropy change, then from here to here, entropy is fixed now. This is S1 and this is S2. So from S1 to S2, S2 minus S1 is equals to what? dq reversible by t and integral from 1 to 2. Are you sure that it is also going to be 0?
If Q reversible is 0, it is 0.
No, 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 no. Q reversible means what? Sum of the Q's is 0. But Q reversible by T, at every point you have to divide it by the temperature and then integrate it. Beta,
Yes,
this is
sir.
last
Yes,
time.
sir.
Yeah, it is not 0.
Yes.
Is that clear? I don't want to just
Yes,
temper
sir.
this one right now. Examinations are very around the corner, okay?
Yes, sir.
You understand now?
Yes, sir.
Good. So from all different parts, one thing is sure, that integral of dq reversible by t from 1 to 2, it will be the same. That is going to be a fact. So one thing at a time. You understand this process, this thing, keep it in mind. Even if q irreversible is 0, q reversible is not equal to 0. Is that clear? Yeah.
Yes, sir.
So in this problem, the first part is this. A lot of theory discussion has taken place in this question. I knew that this question is going to be something like that. Is why I have given a 10 part of it. Think about it. Whole electrochemistry you can revise and then confidently deal with any situation like this. You want to give me a summary of this thing? Are you confused? Ved Prakash, confused or you got some points?
I got some points.
Okay. So kindly do one thing. Whatever it points to, since you're very sincere, just write it on a page. What conclusions you have drawn and send it. So I'll share it on the group also. Although I have written this notes and I'll share this notes with you on this special group. You see that, but this is, it's flowing like question and answer. So neat and clean. What are the conclusions? Like this is a very important conclusion here, which we got. I have wrote it somewhere and then come up with the answers. And now from my side, I will tell that now your examinations are around the corner. Just do one thing in advanced examination as well. 80% of the questions will be not formula based, but based on few notion. Atomic structure, they'll ask radial function, probability distribution of the radial curve. Okay, that you very well know. Maybe angular nodes based on the formula, maybe something like this. If they want to give a twist, like I have given up, shared a problem with you, how many quantum states are there in P2 and P1, P2 quantum states and all this, quickly recognize that this is a special question. Through our discussion, because we have a very little time in the discussion, I just want to make point, have this sixth sense that this problem is special. It requires some special attention, and this is an ordinary problem. So ordinary problem should be dealt with ordinary way. And as soon as you get something like you smell fishy, be very careful. That is what is the physical chemistry requirement is. If you get a tricky question, try to apply your common sense, because examiner will always try to give some clues. Like when I interacted with the toppers, top 10 students many times, like a diamond graphite problem was there. I asked them, oh, such a beautiful problem it is. What kind of problem they have asked? Okay. And that was based on this fact that the formula is delta RG2 minus delta RG1 is equals to delta RV into P2 minus P1 plus minus delta RS into T2 minus T1. And since the temperature is constant, this term will vanish. So I asked students how you have done it. That is such a fantastic problem. Many of them answered, sir, I just saw P2, P1, and I remember a formula V delta P. We just applied it and we got the point at which diamond is converted into the graphite. I was shocked. I taught those kids many times, but there is nothing perfect in this life. In examination, your sixth sense works. Do you agree that you could not know 100% of anything? In 1-2 years time, what do you think? You will understand every perfection with perfection, maths, physics, and chemistry? No. Most of the toppers have this sixth sense, intuition working very well. So when they saw 4 options, they clearly understand, okay, 3 options are not there. This one option is there. So I have seen many shocking things. Sometimes to students after examination, our mind start working like anything. But when you are into the match, T20 match, test match, and something, lot of pressure is there. In that pressure situation, your intuition should develop very well. And that intuition, for that we acquire knowledge. Because then from knowledge, we become very sure this option is not going to be correct. There it saves us time, makes us sure that, okay, this option is going to be correct. Okay. But over knowledge will also sometimes harm as well. So that is why 70 to 80% of the time, physical chemistry paper is very easy. But whenever physical chemistry paper I have seen a coincidence, then it becomes difficult. Then chemistry paper overall is difficult. And that time, whole chemistry paper will be slightly tricky. That happened in 2016, that happened in last year as well. And there, the students like you who have worked really hard on this, all aspects of the studies will get benefited out of it. But if it's an ordinary question paper, set your mind like this, that you are not going to overthink. Simply do the problem, crack it. The problems which I have given you for a very special kind of paper, that is only going to make you aware of this fact that, okay, if something fishy in physical chemistry is there, I will quickly make it out. Okay, this is a good question, conceptual question, and everywhere you just have to apply your common sense. I think I have not given any problem which is not involving common sense. C is for chemistry and C for common sense. And common sense is a very uncommon commodity. So try to use that only common sense. And that common sense is the most important thing. Okay. So please try to share with 5-6 points what we have got here in this discussion, and we will discuss these questions. Also very interesting question, ionic equilibrium problem. Okay. In this cases, the most difficult problems I have taken, they seems to be most difficult, but workable problem. Find solubility of salt A plus and B negative in water. See here, I have not given at what pH will be solubility. See, the K value is 10 to the power minus 13. That means KB is value going to be very large. So these questions are, I just give hint on this one, that A plus B negative is there. A plus is not going to hydrolyze. A plus B negative solid is going to be broken like A plus plus B minus S, and then this B minus plus H2O is changing into BH plus OH minus. This is S and this is S, then this S minus X, X and X, you'll write like this. And you try to solve it like this. S into S minus X is equals to KSP. And the second is X square upon S minus X is equal to KW upon K. So what is the problem? That seems to be very ordinary problem. But whenever you try to solve this problem, you're always going to get a cubic equation like situation. Always you're going to get a cubic equation like C1, C, A, B, C, D is equals to 0. Always you're going to get this. Now you have to be very smart in removing that kind of obstacle. Now you have to take assumption. In subsequent problems, I have given assumptions. The assumptions will be only 2 assumptions will work. One is S minus X is tending towards 0. That means S is approximately equal to X. One set of questions can be solved like this. Okay. Other set of questions will be X is very much less than S. This is the first set. This is the second step. And if these two are not working, the problem could not be solved. So JEE is not a foolish exam where they are going to ask you this. So I can just make your life simpler, that first and second, these 2 approaches are there. Try to see to it that which approach is going to work. These are a very complicated problems. You know why? And they are very calibratedly made. Okay, that is why all this question I have created with a lot of insight. See, if this X is going to be very small, then water's OH negative will also start coming into the picture. So there's a very challenging thing to create a problem like this. So I have to set the value of K and KB in such a manner, KSP, K and KB in such a manner that every time one or other assumption works. So that is the beauty of these problems. So from 11, 12, 13, and 14, the problems which I have given here is set in such a manner that every time you start doing it, you will get one set of assumption going through which the problem will be solved. And my advice to you is once you get the answer, you can always check in ionic equilibrium whether your answer is correct or not. Try to satisfy the equilibrium constants. If it is satisfied, no matter what way you get it, you got the answer. Because in some answers, I myself was slightly get confused and really didn't get the time to thoroughly think about it. And that is why this is the key. This is the key which was initially made. Okay. So there is some objections to it. So I will share this key on your group right now, but please make corrections into this key in today's discussion. Today I will just share your answers once again. Okay, no problem. Don't worry and just respond on the group. Whatever answers you have, I will check and I will just respond. Okay. So I think that now your examinations are very around the corner. If you want any assistance, any topic, if you want to be discussed, you can always ask me and I will just make a note of that thing. If any special notes are there, I will share with those notes with you people or anything else. Okay.